All right, we're going to do some nerdy stuff now. We're going to be graphing piecewise functions. All right, and piecewise functions are functions that are composed of two or more functions. So 3 plus x is the function itself. X squared plus 1 is a function all by itself, but we can put them together, and now it's called a piecewise function. So it's just multiple functions to make one nice function there. All right? So check this out here. In your notes, go ahead and make a nice coordinate plane here because we'll be graphing, and this needs to be accurate for sure here, okay? So this is how this works here. We're going to graph f of x, all right? And we're going to graph f of x in pieces. We have the function 3 plus x when x is less than 0. Okay, that's what I say right here. Use when the value of x is less than 0. And then you have x squared plus 1. The function is x squared plus 1 when x is greater than or equal to 0. Okay, so what I want to do is focus in on this part right here. Let's go ahead and graph the line 3 plus x. Okay, so, I mean, you can think of it as like f of x equals 3 plus x. That's what we're going to do right now. Okay, so, but watch this here, okay? We're not just going to start graphing it randomly. Let's graph it now. It says when x is less than 0, okay, which means not equal to. But let's plug in 0. I understand that we're not supposed to, but watch. This is the reason why, though. If you plug in 0, okay, so I'm going to just do a little table right here. Okay, I'm going to make a little table. Like that. Okay, so these will be our x values, and then we have 3 plus x. You're going to plug it in there, and then you have your y values. Okay, so watch. Let's plug in 0. If I plug in 0, I get 3 plus 0, which equals 3, right? So this is the value 3. So this is the coordinate point. X is 0, y is 3. The point 0, 3. Okay? Now watch this. This is very important here. Because it did not have a line right here, okay? This means this coordinate point 0, 3 does not exist. The point 0, 3 does not exist because it says only when x is less than 0. You can't plug in 0. 0 is not less than 0. However, go to the point 0, 3. Let me just change my color here. Go to the point 0, 3 and put an open dot right there. Okay? This is the whole point of an open dot. It means there is no value there, but we're going to use that because we're going to connect it to this. Okay? Let's go ahead and plug in now values that are less than 0. So let's plug in like -1. So 3 plus -1 is 2. So that's the y value 2. So this is the coordinate point -1, 2. -1, 2. So -1, 2. Okay? Now let's plug in another value that's less than 0. Let's do -2. So that's 3 plus -2, which is just 1. So that's the coordinate point -2, 1. So -2, 1. And as you can see here, I mean, listen, you should know this, that 3 is the y-intercept, and then it has a slope of 1, right? 1 over 1. So down 1 over 1, down 1 over 1. And I could just keep going right here, down 1 over 1. Okay? And so I'm going to go ahead and connect that and then make a nice line now. Okay, but what I need you to understand is that you need to have this open dot, though. Okay? You need to have this open dot. Do not skip that. That's part of the graph. Okay? There's an open dot right there because we can't plug in 0 for this one right here. But if you were to, this is where it would be. But since it doesn't count, we're going to put an open dot there. All right. So now we're going to go ahead and graph the second part of the function. I'm just going to clean this up a little bit. Kind of put this like that. All right. So we're gonna do this other guy here. So I'll just kind of divide that there. So let's do another table. We're gonna do another table here. So a little cricket there. Okay. So if we're gonna do another one here, I'll put x, and then we have x squared plus 1, and then you have your y value. Okay, so let's choose values that are greater than or equal to 0. So always start with the lowest value, okay? Or do the one that's closest to the inequality. So here I want to choose 0. Let's plug in 0. If I plug in 0, I get 0 squared plus 1, which is just 1, right? So that's the point 0, 1. So plot the point 0, 1 then. 0, 1, and that is a closed dots because it says when x is greater than or equal to 0, so I can plug in 0. Okay? That was really bad. Let me go back on that guy. All right, let's try that again. That's still not very good here, I guess. Let me see. All right, let's go ahead and plug in now. Let's see. So I plugged in 0. Now let's do something bigger than 0. So let's plug in 1 right here. Okay? If I plug in 1, I get 1 squared plus 1, which is 2. So that's the point 1, 2. So 1, 2. Okay, that makes sense right here? This needs to make sense. That all I'm doing is I'm graphing this guy right here. We'll do one more. And let's plug in 2. So 2 squared plus 1, that's 5. So that's the point 2, 5. 2, 5. 1, 2, 3, 4, 5. Okay, so do you guys see how this parabola is panning out to be here? And we're going to go like that. Okay, so this is kind of funny because it's kind of like when you cut the graph in half, this side is a line, and then this side is a quadratic, and that's the purpose of that's the way that piecewise functions work, is that they behave differently according to where you're at on the x-axis. And if you know how to graph these even quicker, then you know that this is the y-intercept of the quadratic, and then if you know the pattern, it goes over 1 up 1, over 2 up 4, over 3 up 9, but I'll be showing you that pattern in section 4. Let's do another one of these guys, okay, because these guys are very important here to be able to graph these by hand. That's very important here, is that you're graphing these by hand, okay? And then in class, I can show you how to graph these on your graphing calculator, because they will actually do this for you as well. Okay, what I want to do is I want to graph 2x plus 3. Now, I'm not going to make a table here. We should be able to graph 2x plus 3, right? I mean, this is just a line. Okay, so watch this. I know it says when x is less than or equal to 1, but let's just graph this right now. 2x plus 3. I know that we have a y-intercept of 3, right? And then it goes up 2 over 1, up 2 over 1, up 2 over 1, up 2 over 1. And then the same thing, right? It goes down 2 over 1, down 2 over 1, down 2 over 1. Now watch this. It says that this function f of x only behaves like this when x is less than or equal to 1. Only when x, okay, look at x right here, only when x is less than or equal to 1. So from here on, that's when, so the graph will look something like this, right? Like it's going to go down right here. But and then this right here needs to be a closed dot. Do you see why here? Because x is less than or equal to 1. So I can plug in I'm sorry, right here, 1. Okay, like here's 1 right here. So when x is 1, then this could be a closed dot right there. So the way that your graph will look, starting right here, when x is 1, it will go down. Okay, do you see that there? When x is less than or equal to 1, so that means I need to erase these points over here, because those points are bigger than 1. That's 0.2, and that's 3, 4, 5. Okay. Now, what happens when x is greater than 1? Well, it's going to be the graph for negative x plus 4. So watch this. Let's just graph it, and then we'll erase stuff, whatever. So go to 4. 1, 2, 3, 4. Right? And this means I go down 1 over 1. 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 But the graph should only be seen when x is greater than 1. Go to 1, only when x is bigger than 1. There should not be a closed dot right here, because x is not ever equal 1 right here. So we need to erase that, and we need to put an open dot right there. See this right here? We need an open dot, because if I plug in 1 right here, it says, oh no, x must be bigger than 1. But if I do plug in 1, I would put an open dot. So then you would connect it right there, and it will look like that. And that would be our piecewise function.